Hey everyone, we are the merged group of Kit 10 and 12 from 11 students. And for this video, we will reflect what we did this semester. And we're going to walk you through what we did, the parts that make us crazy, and what we actually learned about problem solving, particularly about figuring out how to get things like servo motors, ultrasonic sensor, and I2C LCD.
The servo motor. A servo motor has a feedback mechanism that allows it to move precisely, usually up to 180 degrees. It is commonly used in projects like robotic arms and walking robots. We also learn the difference between a servo motor and a DC motor. A servo motor is a closed-loop system with controlled movement, while the DC motor rotates continuously in an open-loop system. During the activity, we faced some challenges. Aliyah had trouble due to incorrect power connections, and Rusty, Arduino button, caused the servo to move even without being pressed. Zareen and Jean also encountered coding errors that delayed the motor's movement. Despite these problems, we fixed the issues and achieved good results. Overall, the experience taught us valuable lessons, helped improve our skills, and reminded us to stay calm and enjoy the process.
Next component we tested was the ultrasonic sensor. It measures distance by sending out sound waves and calculating how long it takes for the sound to bounce back to the sensor. We found this really interesting because of how it detects objects using sound. In practice, its reading were affected by factors like the size of the object, the surface, and the distance, since some objects reflected the sound waves better than others. Even with these factors, it still worked well for detecting nearby objects. We used it to detect when something got too close, and once it reached a certain distance, it triggered a buzzer and lit up an LED, showing how it can be used for obstacle detection and simple automation.
I2C LCD. The I2C LCD show all the important info in real time, like the distance measured by the ultrasonic sensor and the system status. It made it super easy to see what was happening without constantly checking the computer. Feedback is really important in robotics because it tells you if everything's working properly and helps you understand how the system reacts to its environment. The I2C also made wiring way simpler compared to regular LCD since it only needed 2 wires to communicate, which made the setup cleaner and easier to troubleshoot. Plus, the LCD was really helpful during debugging and demos because it let us quickly spot problems and clearly show what was going on, making it easy for everyone to understand.
So real talk for when you take this class. Systems thinking is where it actually gets cool. It's not just about one LED blinking. It's about making all these parts talk to each other like a group chat. Like, for our project eye scan, we have the head moving in a loop by a servo motor. But when it moves, the sensor in its eyes is looking for a person. The second it sees someone, it tells the brain to update the count on the LCD and beep the buzzer. If that handoff doesn't happen, the whole thing fails. We saw this even better in that one ultrasonic sensor activity, making the LED flip from red to yellow to green based on distance. That's when it clicked for us. Automation isn't just about magic, it's about constant loop of sense, think, and act. The hardest part of these activities wasn't just the code, it was the hardware. In our LCD activity, the text was popping up before we even touched the button. Then came the ultrasonic sensor. We had this setup where LED should change based on distance, but the yellow LED just refused to light up. We tried different board setups, swap parts, nothing. We didn't just stare at it. We literally held the wires in place to ensure solid connection, and we checked every pin. When we were truly stuck, we weren't afraid to pull the teacher over for a second pair of eyes, and by the end of these activities, our group got way better at the whole debugging process. We really had to lean on each other and stay patient when things weren't clicking.
This robotics experience is gonna help us a lot in future subjects and projects. When we were working with the servo motor, ultrasonic sensor, and I2C LCD, we realized that things rarely work on the first try, and that's okay. We mess up, fix our mistakes, and learn how to troubleshoot instead of panicking. Because of that, future projects won't feel as scary anymore. Even when we see systems like the smart door automation we saw on YouTube, where a sensor opens and closes a door automatically, we can already get how it works at the block level. This class didn't just change how we see technology, it changed how we handle problems in general. Our advice is a simple: don't rush, don't give up too fast, and actually enjoy figuring things out.
Step-by-step procedure is the best way to prevent the errors. We are excited to keep learning, gain more experience, and to apply what we built here to real-world projects.